So today I'm going to explain you our project which we prepared for the preparation of Inter-IIT from IIT Mandi. So the project included that we were given a dataset that was corpus and we were given certain queries in the trained dataset. We had to return certain outputs based on the query from the dataset. It was a basic implementation of RAG. So our approach is as follows. First of all, the corpus.json file, which included the dataset, that was converted into a vector database using Chroma. We used Chroma over here rather than using FAS and other such databases. It is because Chroma allows us to encode the metadata. This feature is not available in uh, other such databases. So this vector database allows us to vector search the queries. So what we do, the second step is the user enters the query. The query is now classified into certain segments. These segments are business, technology, sports. These segments are similar to the categories of the data which you decided in the metadata. This classification of query was done so that more meaningful relevant documents are searched because when we concatenate the query with their classes, it makes the model more efficient and it makes it easy to learn which kind of documents it has to fetch. So after this classification has been made, we do the vector search of the query which has concatenated query and its class, and we fetch the relevant documents. After fetching the relevant documents, a step which is performed later in the code is that we use a Dilberta transformer which was found out through Medium articles, and this transformer converts these documents into, first of all, perform the chunking of these relevant documents, and as these relevant documents in our code are three, from those five most relevant chunks are obtained. This has been done because the size of the documents that we were getting was very large and we could not reduce the number below 1. So the best thing that we thought is that after retrieving the documents for the LLM, as these LLMs are not very powerful, we should do the chunking of the data. So now this this part of the code creates the relevant chunks. These in our code are limited to 5. Now once again the query that was input by the user, that goes through another pipeline. First thing is that there is a transformer called Deberta which is applied on the query. Now this Deberta has been prompted or has been instructed to classify this query into three classes: inference, temporal, and comparison. So this transformer, if the answer of this transformer is inference, we go correctly. If the answer of this, so after I have I have put the query through Deberta, it classifies it into three of these classes: inference, temporal, or comparison. If the class that Deberta classifies the query is inference, then I proceed further. That I'll explain later. But if Deberta does not provide me the class of the query as inference, then it either is temporal or comparison. But as Deberta was not performing well in classifying the query into either of these two, therefore I have used another transformer, that is BART. Now this BART is comes into action only if Deberta gives me that query is not inference. In that case, BART will classify the query accurately into either temporal or comparison. So up till this place, I have classified my query into either inference, temporal, or comparison, and I have got the relevant chunks for this particular query in which I will find the answer. So now I have three things with me. I have the query, I have the relevant chunks, and now I have the class or the type of the query, which implies that I have the knowledge of how the answer of this query will look like. For example, in inference, it will be a one word answer or a short phrase, whereas in temporal or comparison, it will be a yes no answer. Right now, up till this place, I have not classified the null query because I'll explain it later how is it being classified in my code. Only in one place till now I will generate a null query, and that is if the relevant documents that was searched, if that does not return me any document, which implies that there is the query that has been asked is completely irrelevant to the entire document set. In only that case, the relevant documents returned will be 0. and in this case a null query will be generated and the code ends there. But if that's not the case, up till now I have not told you how I am handling the null query. That will come later on. So now if the class is inference, then I have applied the Llama 3.2 model in it, and then it will produce me an answer. If it produces me a valid answer, then that's the end of the code. But there is a second case that it produces me an answer that is not a, that it does not produce me an answer. It gives me an insufficient information. Now, if this phrase is encountered, that implies that query is null query. So now I classify the query as null query as well. Now I come back to the step where I classified the query. Now, if the query was not inference, so part acted upon it and gave it either temporal or comparison. So now either of these classes I have of the query, I have the query and I have the relevant chunks. And once again, I pass it through the Llama model, and then I retrieve the answer of yes or no about how the query has been answered in the dataset. So this is the basic overflow of the final product or the final code that we generated. We also looked at certain other approaches which are clearly mentioned in the documentation. One was through the feedback loop. I will try to explain it if I get time in the end. Otherwise, they are explained in detail in the documentation. So now let me move on to the code file. So this is the collab file that I am here. One second, please bear with me. Okay, so let me tell you how my code has started. Okay, first of all, I have this zip file of vector store. Before that, I'll tell you how I have this requirements.txt that has been installed. After that, through this LangChain and Chroma, I have created this vector store, that is the vector database. Now, this is of course a zip file, and here I have unzipped it, and now I am storing it in the vector store. Okay. Now comes the first thing, that is the Deberta model, where I am classifying the query into these particular classes. Okay, and here I'll work with, okay, so this is the query. Let me show you this thing. So do a particular query is this. Okay, so this is a sample query that I have taken from the train set, and I am using it over here. One second. Okay, so this is a random query that I have taken, and I have run this code. Okay, so here you will see that, so here basically I'll get the label for the query that I generated. So that's completely fine. So now in this case, okay, so here I have this query, and then it has given me two categories for this. First is the business, and then this is the technology. And if you read this query, so then it's quite likely that it is related to both these fields, because software company technology, so we understand that this classification is working well over here. Now the other thing that I told you was that there is a classification of the query into temporal, inference, or comparison. So first of all, it was either through Deberta. If the answer was inference, that was the label that was provided to the query. But in case that it is not inference, then I have run a second model on this, and that is temporal or comparison. In that case, uh, so basically here the query was comparison query. If you read this query, look at TechCrunch article on this, and this both report an increase in revenue. So this clearly shows us that it is a kind of comparison query, and that is accurately predicted by the model. Then I'll run it where this Dilbert model is being used. Now this model is being used to create relevant chunks from the retrieved relevant documents. So now one thing that I like to show you, that the relevant documents that are being produced is this. Vector similarity search has been done. 3 documents have been stored, and from these documents, these documents have been retrieved by. Now in this case, those retrieved documents will be taken and certain chunks will be created from it, which will be, and from those chunks, relevant ones will be taken. So here you can see that it is divided into 43 chunks, and from these 43 chunks, I'll take some of them, and here I'll be using the FAST database to store these embedded chunks, because as you can see that in this case I do not want to store any kind of metadata. So these 41 chunks have been stored in FAS index. Out of these, top 5 will be taken for retrieval. Now over here I am once again running this llama model for this is for the case of inference, and this is for the case if it's temporal, and this is the case if it is comparison. So in this case you can see that the prompts that I have given for along with the query that differs in all the three cases, because the kind of answer that I expect is kind of different. Therefore I have set the prompts differently. In this case, in inference case, I am using the model to as a completely LLM model, but in this case of temporal and in the case of comparison, I have made certain slight differences that I have used it for classification. I have not used for question answer generation, but I have tried to classify this a particular query into two categories, and the category is yes or no category. So this has been done in order to improve the accuracy. So you can see that this is resulted in an answer yes. So that is what the model has predicted. Now I'll run it, and you can see that this is yes. So this is the kind of output that my code is generating. So now I'll tell you, I'll verify if the result is correct. So here is the original data set, and here let me find it. So you can see that here this is the query, this is the answer, it is a comparison query, the title, and this is the evidence list. And here you see the answer, that this is the query, the answer is yes, it is a comparison query, and then this is the evidence list. So that's how my code is working for question 2. Thank you all for being so patient, although I've run out of time, and so therefore I end my presentation over here.